Now discuss the types of emission spectrum, that is of two types, characteristic and the Brahma-Stirling. The basic definition of the X-ray emission spectra is to understand how changes in KVP, MA, time, filtration affect the optical density and the contrast of a radiograph. Got it? I'm repeating the definition. Basically, the X-ray emission spectra is a key to understand how the KVP, MA, filtration and the time affecting the optical density and the contrast of a radiograph. Comes to the characteristic X-ray emission spectra, that is of fixed or discrete energy, and energy which is fixed and or discrete. These energy are characterized of difference between the electron binding energy of a particular element. A characteristic X-ray from tungsten, you can see here, that is of range of different. A plot of frequency with which characteristic X-rays are emitted as a function of their energy, as you look in the diagram. Such a plot is a characteristic X-ray emission spectrum. There are 5 vertical lines, right? Here is the 5 vertical lines which is representing the K X-rays, and the 4 vertical lines that is representing the L X-rays. The other lower energy lines represent the characteristic emission from the outer shell electrons, which is very low energy. The relative intensity of K X-rays is greater than of the lower characteristic X-ray because of the nature of the interaction process. K X-rays are the only characteristic rays of tungsten with sufficient energy to be valued in a diagnostic radiology. So here we have the 5 lines which is representing the K X-rays, right, which is customary to represent them. He has to be done in a single vertical line at a 69 kilo electron volt. When we discuss the emission spectrum in brief, we will draw a single diagram to represent the emission spectrum that we will discuss. Next we are discussing Brahma-Stirling X-ray spectrum. Brahma X-rays have a range of energy and a form of continuous emission spectrum. Brahma-Stirling spectrum is also known as continuous emission spectrum. If it were possible to measure the energy contained in each Brahma-Stirling photon emitted from an X-ray tube, one would find that these energy range from the peak electron energy all the way down to 0, as you see in the diagram. From 0 to it comes to 100. In other words, when we are discussing when an X-ray tube is operated at the 70 kVp, this is a spectrum which is designed for the 70 kVp machine, Brahma-Stirling photons with energy ranging from 0 to 70 kVp are emitted. As you see in the diagram, the shape of the Brahma-Stirling X-ray spectrum is same for all the machines. The maximum energy that an X-ray can have in numerical value is to only kVp operating. That is why we call a kilo voltage peak. What is the maximum voltage a machine contain? The greatest number of X-ray emitted have energy approximately 1/3 of the maximum energy. The number of X-rays emitted decreases at very low energy, and at below kV 5 kilo electron actually nearly reaches to 0. Here is the graph which is a combination of Brahma-Stirling and the characteristic emission.